Okay, so today we're going to be doing 16.2 volume of pyramids, and then we're also going to be doing 16.3 volume of cones. They're essentially the same thing. They're kind of like finding the volume of a cylinder versus a prism. It's going to be the same formula. So I was just separating the book for some reason. So to find, so what is a pyramid? Let's go over that first, since we went over the definition of a prism before. So a pyramid is once again a three-dimensional shape with only one base. Before we had two bases, now we only have one. All right. So now our base is connected at one single point. At one single point. So a pyramid and also a cone is going to be a three-dimensional shape with only one base. The way we're going to find the volume of a pyramid is by using this simple formula. Once again, we're going to be using V to denote our volume. It looks more like a U. V. Awesome. We're going to be using V to denote our volume. This time we're going to multiply whatever we get by a third or divide by 3, whatever you want to do. It's the same thing. We're still going to be multiplying by the area of the base, which is still big B, and we're still going to be multiplying by the height of the pyramid or cone. Like I said, it's going to be the same exact formula. All right. So here we have our first pyramid. Here we have our first pyramid. Pyramid. So we're going to be using the formula we just went over, which is going to be the volume is equal to 1/3 area of the base times the height. In this case, what type of base do I have? Yeah, we have a square base. So how are we gonna find the area of the square base? It's going to be length times width. Since it's a square, it's going to be the same number. So it's going to be 24 times 24. And again, I don't have a calculator, so let me pull out my phone. 24 times 24. That's going to be 576. So the area of my base, my big B, is going to be 100 and 576. Now, my H, I need the height of my my pyramid. So the height of my pyramid is going to be 16. So once again, I'm just going to plug in 16 into my formula. So that's going to be, if I plugged it in right, that's going to be a total of 3,072. Once again, we're going to be using our units, and we're going to be doing cubed because we're finding the volume. Cool. So here is more of a word problem where you have to actually kind of have to draw your pyramid. Once again, pyramid. So we have a pyramid. We have the Great Pyramid of Giza, I don't know what that is, in Egypt, and it is approximately 146 meters tall. So if it's 146 meters tall, that means that it's probably going to be talking about my height. And that's going to be 146 meters. Let's try to draw. Let's just finish reading the problem. Also, we know that the pyramid has a square base, so the base is going to be a square with a length of 230. So in the problem back here, we also had a square base with a length of 24. Since it's a square, we know that all the sides are going to be the same. So if we have one length of a square being 230, that means that all the lengths of the square is going to be 230. A square, and then meeting at one point. That's ugly. Okay, so the base of the area of the base of my pyramid is going to be length times width. We know that the length is going to be 230, so we're just going to multiply 230 times 230, and that's going to be, I keep messing it up, 230 times 230 is going to be 52,900. So the area of my base is going to be 52,900. That means that my volume of my pyramid is going to be 1/3 the area of the base times my height. Now I just have to plug in my numbers. Times 146. So we're gonna multiply my big number, 52,900, times 146, and then divide by 3. That should give us 2,574. Oh, that's a big number. So that should give us approximately 2,500,074 466.67, and that's going to be meters cubed. I don't know who decided to measure this volume of this pyramid in meters, but he gave us a big number. All right, if you want to learn how to draw prisms, pyramids, you're going to draw your base just like a regular square. I'm gonna have to kind of do it slanted like I have it here, and then pick a point, any point on the top, and then just connect all your lines. You're going to want to have this corner being kind of like a dash line, or just don't connect it at all. This is supposed to be behind it. You're not really supposed to see that vertices. And then also, if you remember, you can also make this line dash and this line dash. But yeah, that's how you draw a pyramid. Anyways, like I said, we're also going to be doing the volume of cones. Again, a cone is just a three-dimensional shape with a circle base, one circular base. The volume of the cone is going to be exactly the same. We're going to take the area of the base. In this case, we have the area of a circle times the height divided by 3, or times 1/3. They're essentially the same. All right, so the first one is going to be a circle. I mean a cone. So first, we need to find the area of the base. The area of a circle is going to be pi r squared. My radius is half of my diameter. The number that they're giving us right here is the diameter of 2.2. So in order to turn this diameter into a radius, we're going to divide it by 2. So my radius is going to be 1.1, because 2.2 divided by 2 is 1.1. And I'm going to plug in my radius into my area formula. It's going to be pi times 1.1 squared times pi. And that's going to be approximately 3.79. We're just going to call it 3.8. Keep it simple. All right, so that's the area of my base. Now we're going to plug that into our volume formula. We're going to have a volume is equal to 1/3 of the area of the base times the height. We just figured out that the area of my base was 3.8. And we also know that the height of my base is 1.8. Because they gave it to us. I got that number from right here. I'm just plugging it in. So we're going to plug that again into our calculator. All right, I messed up. That was a 2. This is supposed to be a 3. I had a 2 right here. I changed it to a 3. We're going to do 3.8 times 1.8 divided by 3. So the volume of my cone right here is going to be 2.28. Like I said last time, I'm not really going to be too stressed about the way you round, just as long as you're doing the process right. All right, so sub, if you could just pause it for a second, let them try it on their own, give them about 5 minutes, and resume the video. Thank you. Awesome. So what you probably did was first you were trying to find the area of my base, which is a circle. So we need a radius, because area of a circle is pi r squared. So what you probably did was divide my diameter by half, by 2. Sorry, you're going to divide my diameter by 2, and that's going to give you a radius of 1.2 inches. All right, so now you're going to plug that into your formula, and you're left with pi equals 1.2 squared. So 1.2 squared times pi is going to be 4.5. Right, so that's going to be the area of your base. So you're going to plug that into your volume formula, which we should know by now. It is volume equals 1/3 times the area of the base times the height. I'm going to plug in my numbers. We just found out that the area of my circle is going to be 4.5. So I'm going to plug in 4.5 for my big B. My picture that I have on the left shows us that our height is going to be 3.9. So I'm just going to plug in 3.9 for my height. Okay, sorry about that. Now we can just plug that into our calculator. We're going to get 4.5 times 3.9 divided by 3. And that's going to be 5.85 inches cubed. Again, we just need our units and our cubed since we're finding the volume. I forgot to do that here, but that's going to be inches cubed as well. Cool. So I'm pretty sure this is very similar, if not the same, as problem number 9. Problem number 9 in 16.2. So I just wanted to show you one of those problems. And then we're also going to do one from 16.3. Yeah, we are. Cool. So 16.2, there's this thing called a composite figure. I don't really know what that word means, but by context clues, I just figured out that it was two figures that were to put together. So we have a pyramid and we have a prism. So we're going to need to find the volume of the pyramid, and we're going to have to add it to the volume of my prism. So I'm just going to break it down into 2 steps. Volume of pyramid. That's going to be my first step. Cool. So the volume of my pyramid, I'm just going to block out everything at the bottom for now. I don't have to worry about it. Awesome. That's cool. I don't know if you guys saw that, but my Apple Pencil's about to die. All right. So we need to find the area of the base of my pyramid. Since this is a square, we know that my length is going to be the same as my width. Since this is also a square, we're going to know that this base is going to be the same as this base. Whatever the area for this base is going to be the same as this one. So 12 times 12, because it's a square, so we're going to do area equals length times width. So 12 times 12 is going to be 144. So we're going to plug that into our volume formula, which is 1/3 big B H. So we're going to have 1/3 big B, area of the base, which you just figured out is 144, times a height of 18. So we're going to plug that into your calculator. We're going to get 144 plus 18 plus 18. 144 times 18 divided by 3. It's going to give us 864. All right, so that was the volume of the pyramid. Now I need the volume of the prism. I need the volume of the prism. Here I have a cube. This prism is called a cube because all the faces are exactly the same. It's going to be the base of the cube times the height. We already figured out the base of the cube because it's going to be the same as this one. This base is the same as this base. So we're going to plug that into our formula for our prism. Once again, I spelled prism wrong. I'm so sorry. Prism. There's going to be big B times height. Big B, we already know, is 144. and we have to multiply that by 12. So it's going to be 144 times 12, and that's going to be 1,728. Am I done? No. I'm trying to find the volume of the composite figure. So I need the volume of this pyramid plus the volume of this prism. So I'm going to add my 864 plus my 1728. I did not mean to do that. That's funny. All right, so 1728 plus 864. 1728 plus 864. That's going to give me a total of 1728 plus 864. That's going to be equal to 2592. If you're paying attention to this video, please on your 16.2 homework, write a big 1728 with a bunch of exclamation marks. Cool. This one's going to be exactly the same as the last one. You're going to find the volume of, actually, let's do it. We're going to work that one out. Before that, we're going to do 16.2. This is going to be question number 7. I'll do this one with you because it involves a lot of moving variables around. So, my problem says, given a square pyramid, it's a square pyramid, is going to have a height of 3 inches and a volume of 21 cubic inches. We have to find the length of one side of the square leg. All right, so this problem is different because instead of giving us the area of the base and the height, it gives us the height and the total volume. So don't overcomplicate this. Just rewrite your formula. Just how we've been doing every single time. Just like we've been doing every single time. Rewrite your formula. There's no reason to skip this step. Just rewrite your formula. All right, now we're just going to plug in what we know. We know that the height of the pyramid is going to be 3 inches. So instead of plugging in my height, I'm going to plug in my 3. We also know that the volume of the formula, the volume of the pyramid is going to be 21. My 3's are going to cancel out because 3 divided by 3 is just 1. So they cancel out. And I'm left with 21 is equal to B. I'm left with 21 is equal to the area of the base. The area of base is equal to 21 inches. Awesome. So the area of the base is equal to 21 inches. The question's asking us for the length of one side of a square leg. The area of a square is just length times width. Since this is a square, our length and our width have to be exactly the same. So this is just like saying we have to multiply one side by itself. So we can just put an s squared instead of length times width. And we know that the area, by doing all of this, is going to be 21. So I'm going to replace my area, for 21. So now I need to get this s by itself. What is the opposite of squaring a number? You gotta square root it. So we're gonna square root our s, and we're gonna square root our 21. My 2 and my square root cancel out. I'm left with an s, and then this is going to be a big decimal. So this is going to be 21 square root. I believe it's gonna be 4.58. 4.58. 4.58. 4.58. So the side of my square base is going to be 4.58. So let's go back to this one now. So once again, we have to find the height of the entire cylinder, and we're gonna have to subtract by both of these cones. We're going to have to subtract by both of these cones. We're gonna separate it into two separate problems. So first things first, volume of cylinder. The volume of a cylinder, if you guys remember, is going to be the area of the base times the height. So first we need to find the area of the base. We know that the diameter is going to be 12 inches. So to find the radius, we need to divide this 12 by 2. So my radius is going to be 6. We're going to plug that into my area formula. So pi r squared. Instead of r, I'm going to write 6 because that's my radius. And that's going to give us an area of 6 times 6 times 3.14, 113.04. I'm going to erase this part of the work. So if you want to copy it down, please ask the substitute to pause it. 113.04. Okay. So the volume is equal to base times height. The base is going to be 113.04. Now, the height of my cylinder is going to be, again, 12 inches. So I'm just going to plug in a 12 for my height. So we're going to multiply 113.04 times 12. And that's going to give me 1356.48. 1356.48. That's going to be the volume of my entire cylinder. So if we want to find the area of this shaded area, if we want to find the volume of this shaded area, we have to find the volume of this cone and the volume of this cone and subtract it from the volume of the total cylinder. What we can assume, and I'll let you assume this, I know it doesn't say it, but I'll let you assume it, is that the volume of this cone is going to be the volume of this cone. All you have to do is find the volume of one and then multiply by 2. So let's find the volume of this cone. Volume of cone. The volume of a cone is represented by 1/3 base times height. So now we need to find the volume of this base. We already did that. We got 113.04. We're going to replace my big B with 113.04. Now, my height. You might want to say that my height is going to be 12 inches. But remember, we're finding the height of this cone separately. So instead of the height being 12 inches, it's going to be half of the cylinder's height. And that's going to be 12 divided by 6, 12 divided by 2, which is equal to 6. So now you guys can plug that into your calculator. And it's going to be 113.04 times 6 divided by 3. 226.08. That's what I got at least. All right. So to finalize this problem, to finish this problem, we have to do the volume of the cylinder minus 2 times the volume of cone. So again, we have 2 cones. We have to multiply it by 2. So it's going to be 1356.48. I just grabbed this number from up here. Minus 2 times 226.08. So 2 times 226.08 is going to be 452.16, 1356.48. And that's going to be, I ran out of space, 904.32. Cool. So I think looking at the homework, you should have enough information to do all those problems. Yes. All right. So today you're responsible to work on 16.2 and 16.3. I saw that a lot of y'all finished 16.2 right after we did right after we had only finished 16.1. So I'm glad that you guys took that initiative and got that work done. I hope that you guys didn't just look up the answers online, but I have no proof. So you do you. All right, good luck once again. Please feel free to ask me questions, and I'll see you later.